Hey everyone, in this video we are going to look at making a simple first-person perspective 3D maze game. And this is very similar to a 2D maze game I made not too long ago. Obviously the main difference is it's going to be first-person perspective and it's a 3D environment, but that doesn't actually change all that much. So to mix things up a little bit, create a little more variance from that project, we are going to use a different control scheme. In the 2D maze, we simply use WASD. In this, we're going to use some pre-packaged control schemes that come with Unity. Also, the maze itself, if you want to see how that is made, the modeling is done in Asset Forge, and it should be the video immediately previous to this one. If you are on my channel, I will also include a link in the description so as that you can watch it that way if you're interested. So let's go ahead and take a look at some of those built-in control schemes. So if you go up to Edit and you go down to Project Settings, if it's not already chosen, click on Input, and here you'll see the various types of input that Unity is able to recognize. Now, the first thing you're going to notice is you're not going to see left analog stick or right analog stick or anything like that, because that's not how Unity sees a controller. Unity sees axes. So the left analog stick, if you're moving left and right, that's known as the x-axis. If you're moving up and down on the left analog stick, that's known as the vertical axes. Now, what about the right analog stick? Well, that left and right on the right analog stick would be what's known as axis 4, and then vertical on the right analog stick would be axis 5. I believe if you're using a PlayStation controller, it's slightly different. And then if you're using like an off-brand or a Logitech or something, then the axes might be slightly different there as well. But yes, that's the big thing you need to take away, is that you won't see individual analog sticks referred to or D-pads referred to. It's looking at different axes. Okay. Second thing is, even though there are built-in controls for the left analog in the form of the X and Y axis, you don't see any built-in here for the right analog. So basically you have to configure that. So that's why I came here first. We'll get that out of the way, and believe it or not, this is the worst of it once we get past this. And really the explaining it is worse than the actual understanding. So down here you'll see horizontal, let's expand that, and vertical. So horizontal, and this is referring to horizontal on the controller, not horizontal in the world necessarily. And what you'll notice, type joystick axis, axis the x-axis, and any of the joysticks. So you could change this to say just joystick 1. That way someone can't fiddle around with the second joystick, but that's one of the ways that you can differentiate which controller you're getting information from. But for the purpose of this, we're really just going to worry about these two, and we're going to worry about the dead zone in a minute. So this is left and right on the left analog stick. This is up and down on the left analog stick. So similar, you can see it says joystick axis, it says Y axis this time instead of X, because again, it's breaking down the analog stick into two axes. And then again from any joystick number. So that lets you move along one axis in the environment. This one will let you move along another axis, and since you can do a combination of both, then you can move along a two-dimensional plane. We're not going to do any vertical movement in this. But what that doesn't let you do is that doesn't let you rotate. So this is just moving your position. So obviously, if you're in a first-person perspective, you need to rotate around too. So you need a third axis to monitor. And this is what I was saying, that even though a right analog stick is very common in gaming, there isn't anything predefined for this. So we've got the left, the two parts of the left analog stick, but nothing for the right. So basically what you have to do is you have to repurpose one of these other ones. If it's something that you don't need, then you just repurpose that one. So right now this is checking for the mouse. We're going to wipe that out. We're going to wipe out using the mouse. You're not going to use the vertical on the mouse. Now the name is really irrelevant. The name is simply what you're going to call this. So we're going to call this look around. So again, that doesn't actually do anything to the functionality. That's just what the name you call it by. Kind of like when you create a variable in C#, the name of the variable means nothing except to you, the designer. So we need to change this from type mouse movement to joystick. We need to change this to fourth axis. So again, on the right analog stick, left and right, horizontal, is the fourth axis. If you wanted to do up and down on the right analog stick, that would be fifth axis. So again, I don't know why they don't have this built in because, again, having two analog sticks has been in gaming for years. I do want to call out the dead zone and the sensitivity. So dead zone is when you have an analog stick, okay? So you have a range of numbers. You don't want it to be too sensitive because if you tap it a little bit, you don't necessarily want to register that. So what you do is you can create a dead zone where if it's really weak, then we can change it to make it stronger. But for now, we'll leave it to 0. We will come back here at the end as part of the fine tuning. I don't want to get that into too much of that now. I just want you to actually see the results of how we set this up. So again, the explanation is way worse than the understanding. You're just configuring where the input is coming from. In fact, like if you wanted to, for vertical, since vertical is misleading, you could call it, say, forward if you wanted to. But for now, we'll stick with this. And we'll close that. And now we can actually get into designing and coding the level. Okay, so let's just take our maze object. We're going to drop it in the scene. As I mentioned, I made this in Asset Forge. And I'm going to have a separate set of videos talking all about Asset Forge, but I already did post one about making this particular object. Now it came in a little small, so what we're going to do is we're just going to scale this. So with the object selected, oh, and by the way, actually let's make one change. I don't know why Unity does this, that if you have a 3D asset and you put it into the scene, it adds this. And this is basically an empty object except for transform. This has transform, so I don't know why it insists on creating that redundant top level parent. So what you can do is you can just unpack prefab, drag that away, and then get rid of that. And then what you can do is you can create a new prefab. So we'll call this Maze 2. It doesn't really matter. And really doesn't even have to be a prefab, but if you're going to use an object over and over again, you can just drop it in there, and that creates a prefab. And you can see the little, how this is like a colored cube now. It indicates that it's based on a prefab. Again, for this particular project, you don't have to, but we will do it anyways, just so you know what it's like to create a prefab and why you would. So let's scale this out. Let's make this like 3 and 3 and 3. I'm just kind of eyeballing it. All right, so that actually puts our camera just about in the right position because this is meant to be the start. And you go around, you got a couple of dead ends here. And you can come through to the exit there. You can see the doorway. And you can see we even put a little hole in the wall here to make it able so you could see through, so you know where you need to go. Again, this isn't meant to be a challenging game. It's just meant to show you the basics and some of the things you might want to do with level design. So what we're going to do, we're going to take that camera and we're just going to move this over a little bit. And you can see what the perspective looks like there. In fact, it's rotated this way. You can see the lines going out. So we'll click on the rotate tool. And we're going to rotate that so it's facing along that axis. And then we just clean up the rotation here to an even 90, although that will change as you're moving around. And what you might want to do, you might want to change the field of view. I'll show you why in a few minutes. So we'll get to that shortly. So in a first-person game, there might not actually be an avatar, a playable not a playable, but an actual visual for your character that, unless it's multiplayer, you might not actually have to design a character because it's all from the first person perspective. So what we're going to do, we're just going to use the camera. So we're going to click on Add Component. We're going to click on physics, and we are going to click on character controller. So if you've watched any of my videos, usually when I'm using movement of a character, I usually use a rigid body. There are certain benefits to using the character controller, which we'll get into in this video, but you can control a character either way. Both have benefits, both have detriments. We're just going to go with the character controller, if nothing to be different, because like I said, I don't want to duplicate what I've taught in another video. I want to always be able to teach you more. You can leave these as all their defaults for the moment. So that gives you your character controller. You also need to have collision detection, or else you could just walk through all the walls. So that's true for this and for the maze. So let's go ahead and add our colliders. So add component, we're going to do physics, and we can just do like an orb, like a sphere collider. And then you're going to have to decide what size you want that collider to be. Because here's the thing about a camera. Depending on the field of view, okay, you might be so close to the wall that the camera sees through the wall because you've actually passed through the camera, so passed through the wall. So what you're going to do is you want to make sure that the combination of the collider surrounding it and the field of view doesn't let that happen, and that's just kind of trial and error. So like for instance, if you want something to seem like, we'll take the slider here for field of view. You can see that as you change the field of view, it makes things look closer. You increase it, makes things look further away. So you'll use that, like I said, in combination with the actual size of the collider to keep you from being able to see through walls. So what we'll do, let's actually increase the size of that sphere collider. At the moment, you can see these little dots appear. You can kind of just expand them out. What we'll do is we'll need to recenter this. So let's change that back to 0 and that back to 0. Now we have a larger collider. There you go. And also don't make the collider so big that you can't fit through the corridors, but you can always just scale the maze more if that's the problem. Okay, so now the maze needs a collider. Now if everything works as intended, that if this is like properly formed and properly imported and that kind of thing, because some applications don't seem to work so well with Unity, and that's really true about any engine. But if everything works according to the way it should, what will happen is you apply the you apply the collider. We're going to use a mesh type collider. It will automatically conform to all these walls. Now, if you watched my 2D one, when we applied the collider, it did not. It basically made a spider web and we had to spend a couple minutes cleaning it up. Here, it's much more exact, so it should conform exactly right. So with our maze object selected, we go Add Component, Physics, and then we do Mesh Collider. And depending on what you're doing, it either needs to be convex or not. We'll just test that, and we'll know right away what it needs to be. Now we start coding, and we'll actually be really close to be done at that point. So right-click, Create, C#, and we'll just call this Move Around, if I could spell. We go back to our main camera, which is also standing in for our player. So we attach the sphere collider, we attach the character controller, and now we just attach our script. Now let's get rid of this line because this is not executed. This is simply a remark statement, so it's for internal documentation only. Same for this one. And now what I'm going to do is I'm going to paste in 3 lines of code, but I will walk you through it. I just don't want to waste your time you watching me type and make typos. So what we're doing, we're going to create 3 variables. You can really call them whatever you want. I call this one ROT, short for rotation, because that's handling the rotation. So this gets back to what we were saying a few minutes ago at the beginning of the video when we said that there were pre-made schemas for the control. So there is horizontal. So this is saying this variable is going to be equal to when the input that's being received is the axis of horizontal. Again, it sees everything as either an axis or a button click. So for the analog stick, it sees an axis. Okay, so the reason why we're putting that into a variable, because what happens is the next part of the understanding of how this works is the fact that when you're pressing on an analog stick, the range is from 1 to -1 and 0 is at rest. So what we're going to do is ultimately when you're clicking on, when you're moving the analog stick, it's just giving a number. Again, ranging between 1 and -1. So since it's just a number, we're just going to use that in the calculation. So rather than saying, if this is being clicked, then do something, we're just going to take that raw number. It's giving us a number. We're going to take it and we're going to apply that to the movement and rotation. So again, horizontal, we looked at that one. It's for axis X. Vertical, this one was axis Y. I called it float Z. Don't worry about it. Doesn't really matter. And the float rotation, this is when we repurposed what was originally mouse Y. We changed that schema to change to the look around because it's going to be used for rotation. So this is what is referred to as axis 4, we said. Now I'm going to paste in 3 more lines of code. We will again review it, and then that will just be about it. There'll be 1 more line after that. So the main thing that we're going to do, we're taking these values and we're simply putting them into a calculation. So this is yet another variable. So this time it's going to be a vector 3. So that means, so this is the name of the variable. It can be whatever you want to call it. And this is the type of variable. So it's a vector 3, and we're just calling it move calculation, so move cal. Transform.right. So when you have an object in a 3D environment, you can choose by default, based on whatever the front of the object is considered, to move left, to move right, to move forward, to move back. So you can choose transform.right, and then the number that's applied to it. If it's a positive, you're moving right. If it's a negative, you move left. So what we're saying, and again, transform, without anything in front of this, transform is being applied to whatever object the script is attached to. This script is attached to the main camera. So this is saying that we're going to move the camera to the right, and we're going to have a calculation. 1, what is the X? Right here. So remember, the move to the right is going to be from 1 to 0 to -1. And we also want to apply forward. So in other words, you're not moving along just one axis. You're moving left and right, but you're also moving forward and back. So unfortunately, there's not too much I can do. It looks messy, but it's just the way that it works. Just the big takeaway is that rather than knowing exactly what direction you're moving in, you're saying the subjective right. In other words, whatever this object's right is, move in that direction. So you're not trying to move absolute right to whatever the right of the environment is. You're moving to the character's right. So in other words, this is taken into consider rotation. So again, vector 3, and we are going to have the transform right, and we're timesing it by the input for the X, and then transform forward. So we're moving right and forward, and this is multiplied by that Z variable. So in other words, you're taking all this and you're dropping it into here. You're taking all this and you're dropping it into there. And that's the main thing that's moving your character, at least actually, it's not moving your character, sorry. That's creating the vector3, which is going to be used to move your character. So these three are variables of a float type. This is a vector3 variable. Now, we just need to say what that is. So that's the last line of code that we need to do up here. So this controller is referring to this, and it's a character controller. So controller.move. So as I said, this isn't the actual movement. This is the calculation. So now you're saying move. So controller.move. Again, this controller we're about to assign right here, and we're going to make this change to that controller. We're saying move by the move calculation, and then some arbitrary multiplier so it's not too slow. And the reason why you're doing time.delta time is, see how this is taking place in update? Update runs once per frame, every frame. So in other words, if you have one system running at a slow frame rate, this would be calculated slower. If you have another running at a faster frame rate, this would be calculated faster. So in other words, it would actually take you longer to accomplish a task on the slower version. So by multiplying by time.delta time, what this says is, what's the change in time been? If you remember math, delta is change in, okay? So what's the change? The change in time. So in other words, this is adjusting for frame rate. That's really all that's doing. So it looks messy, but that's all it's doing. That way you don't get different behavior based on frame rate. And then we just say get component, transform, and now we're doing rotate. And again, we're using a vector3, and this time it's up. And we're using this variable. And then again, we're just multiplying it by an arbitrary amount to keep it from being too slow. So it's messy, but a lot of what you're doing, you're creating variables, then you're applying it. So if you want to break it down that way, these are the variables. This is taking those variables, at least two of them, and putting it into another variable, then applying it to the controller for movement, and then this applies it to the transform component for rotation purposes. Now we save that. We go to our main camera, and you'll see controller here. So it might seem redundant, but we're going to take its own controller and put it there. And if I have not made any mistakes, which would be a first, if I did not make any mistakes, this should work. Okay, see how it's drifting ever slightly? That's the dead space I was talking about. If you create a dead space, it won't drift like that. So let's take care of that first, so you can see in an iterative manner how this works. So we'll go back to project settings. That was look around, see how no dead space. So let's make this like 0.01. It's got to be a really low number. We close that. There, drift is gone because now you have a dead space. Now you have a little bit of literally wiggle room where where there's not any input being accepted. And there's a right analog stick. This is forward. Really fast, so I might want to change those numbers. That's back. And now let's see if we accidentally see through the walls. Nope, that's actually just right. And it looks like it does not need to be convex because it's not giving us a problem. And then just like that, you now have a first-person controller. It's really the basis of any kind of first-person game. So whether it's like a narrative adventure like Going Home, or a first-person shooter, first-person survival horror, doesn't matter. You now have navigation. So this was what I was talking about. You can see through the wall. Looks like our character might be a little bit low, but that's fine. And you could do things like that. That's more of a level design thought rather than an actual coding, because you might not want to do that. You might not want to give people hints. And then really that's it. So that's the 3 axes. So we've got forward, back, left, and right. Now, left and right doesn't do much for you because the hallways are narrow, but a lot of first-person shooters you need to strafe. That's what the left and right is doing. You're strafing because you're facing one direction but moving in another. The rotation's probably a little bit slow. And that's it. So if you want, we can do a few other things in a second video, such as adding a key that you have to pick up, having a door that's locked that you can't get out of. But again, I already showed how to do that in the 2D version, so I didn't really want to waste anyone's time. That would work almost exactly the same way. But if you want me to do another video that covers that, what we'll do, that's why I put these dead ends, like maybe we'll put a key here, so you got to get a key to the door, and then we'll add, like a friend or something here that you have to pick up, and then you can exit, that kind of thing. So if you want to see that, just leave a comment. But like I said, I already put that in the 2D version, and the collision detection and all that should work just about the same. But yeah, if you want to see that, just let me know. So yeah, I'm surprised that went through the first time. I usually make some kind of typo or something, but I believe that was everything that we're looking for. And I hope you found this useful, and please enjoy the rest of your day.